Question 4 asks you to describe the graph of arcsecant, which is given to you. Now, the first thing we should notice about arcsecant is that the input is going to be the ratio of the hypotenuse to the adjacent. Normally, secant of x is equal to the ratio of hypotenuse to the adjacent. So for the inverse of secant, which is arcsecant, the input is going to be the ratio of hypotenuse to adjacent, while the output is going to be an angle. So first thing we notice about this graph is that it has a point at 1, 0, meaning that when x equals 1, the output equals 0. So let's think about what this means. It means that the hypotenuse and adjacent ratio is equal to 1. So the hypotenuse and the adjacent are exactly the same. So when we construct our triangle, if we were to draw our adjacent side like that, well, the hypotenuse has to have the same length. And that means that the hypotenuse, that the ratio of hypotenuse to adjacent is 1, but also it means that the angle is 0, because if we tried to make a non-zero angle like that, well, now the hypotenuse and the adjacent are no longer the same length. So what we have here is it just is basically a straight line where the hypotenuse and adjacent are the same, and our reference angle is just equal to 0. Now, what happens as the ratio of hypotenuse to adjacent gets larger and larger and larger? Well, let's look at an extreme case. So here's our adjacent side. We're going to make our hypotenuse really big. Okay, well, what happens to that reference angle? Okay, we look right here. It looks like it's about more like 90 degrees now. And if we make the hypotenuse longer and longer and longer, it's going to keep swinging up further and further and further. Let's draw a triangle where the adjacent side is so small compared to the hypotenuse that we can't even really see that there's an adjacent side there. Well, that angle is going to be basically exactly 90 degrees. So when you look at this graph of arcsecant, that's why it looks like this. It's approaching 90 degrees asymptotically as our x value, the ratio of h over a, gets larger.